Hi everybody, this is Mr. Nardelli. I wanted to talk to you a little bit about scientific notation. I know it was in Module 4, but it was not on the test, as far as I know. So I do want to go over it with you on our next meeting, which will be on the 26th, I believe it is. If I have that date wrong, forgive me, but that Thursday. So, scientific notation. First off, it is used to represent very large or very small numbers in a more compact and convenient way, particularly in science, mathematics, engineering, and, ta-da, nursing. So, like if you have a large number like 800 million, it's a real pain to write down all those zeros and add them and subtract them. Or if you're talking about something like the size of an insect, that might be 0.0004 of an inch or something like that. It's just a nicer way to write things. So the different parts of the scientific method writing. The number in the front is called the coefficient. The 10 is the base, and the base is always 10, and there's an exponent. So you'll notice we have positive and negative exponents. One of the things about the positive and negative, large numbers have positive exponents, small numbers have negative exponents. That kind of goes hand in hand to easy to remember. Large might be a large number, small might be a small number. Notice this coefficient is always a single number followed by a decimal and then numbers after it. There can be a multitude of numbers after it. Generally it's 1 or 2 or 3 or so. And this number can be by itself. Okay, so I've got some information here. I'm just going to kind of drag this. So, some examples. And I've got some rules here, but we'll go over them. And I slipped a little bit, so sorry about that. Okay, there, that's better. So, notice I have, I don't even know what this is. 49 million something or other. It's a lot. And notice each of these numbers, these first three, are large numbers. Look at the exponent. They are positive exponents. These are small numbers. They're negative exponents. You're not at this point expected to read this like 97 whatever that billionths or something. You don't have to worry about that. But some of the rules are actually the main rule. And I actually should have, let me bring this down a little bit. Oh, no. Oh, there, that's good. Okay, the coefficient must be a single digit. It can be followed by digits. It can be by itself, but it can't be something like 10. So, it basically is 1 through 9. I had another rule here. Yeah, there we go. Bring this guy down a little bit. And do that. Okay. We're working as we go along. So, if the exponent is positive, you move the decimal to the right. If it's negative, you move it to the left. So, what this means, I'll just put my rules right there. Get them out of the way. So, this large number, I would start, if I need to put it in scientific notation, I would put 4.9. So I look at any digits that I have that are non-zeros. I call it 4.9. Then I do times 10. It's always going to be times 10. Now I'm going to look at my decimals place. There's my decimal right there normally. I'm going to count the number of jumps until I get to 4.9. 1, 2, 3, 4, 5, 6, 7, 8. And I have an 8 as my exponent. So, this large number, notice I put 1.23. So I've got a little bit more. Times 10, and then I move it 1, 2, 3, 4, 5, 6, 7, 8, 9. Now I'm going to skip the 5051. I'm going to jump to this small one. You should look at that and think automatically, that's a small number, it's going to be something to the negative something. So I just go to the digits that are non-zeros. I call it 9.7 times 10, and then I'm going 1, 2, 3, 4, 5, 6, 7, 8. It's a negative 8. This one's a negative 5. Notice what I did each time. I actually physically jumped. So, if you need, I suggest, and yeah, you're doing it on your computer, use your pencil. Don't write on your computer, obviously, but do the number of jumps. Because counting, your eyes are going to get all blurry and it's going to be a little tough. Okay, so I'll tack those rules back up there. Well, let's just put them right there. So let's do a practice question. Convert this thing into scientific notation. So yeah, I could call it 46 and something billionths or whatever, but I'm not worried about that. So think to yourself right away, okay, first thing I have to type is just my 4.6. Then I need to do times, and I put a capital X, you could put lowercase, and you can put the dot if you want. Okay, times 10. So I've gotten that point down. Now I need to think to myself, is this going to be a negative or a positive exponent? Well, it's a really small number, so it's going to be negative something. So I have to do superscript. So negative, and then I'm going to have, 8 or something, whatever the case may be. So I'm going to do my jumps. 1, 2, 3, 4, 5, 6, 7. So it's a negative 7 jump. And that's how I convert that one. So my answer is 4.6 times 10 to the negative 7th. Okay, let's try this big guy. Okay. So immediately I'm going to go to just my non-zero digits. But I do have to include this 0 in the middle because of this 1. So I'm going to call it 3.01. Then I'm going to say times 10. And it's going to be 10 to the something or other. Now I'm looking at it, it's a large number, so it's going to be a positive number. So I've done most of my work now. All I need to do is find out what that positive exponent is. There's my decimal, it's understood at the end. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. That's a positive 8. Boom. There I go. So I have a 3.01 times 10 to the positive 8. We just call it 10 to the 8th. Okay, let's go the opposite direction, and let's say you are given scientific notation and you want to put it in big form, whatever the case may be. Standard form. Yeah, that's the case. So let's look at this. It's 1.36 times 10 to the 7th. That's a positive exponent, so that means it's going to be a large number. So it'll be these digits followed by some zeros. So I'll just type out 1.36. So I'm going to have to determine the number of zeros. I'm going to look at this number right here. It's at 7. This decimal is going to have to jump 7 places. Now, not 7 zeros, 7 places. So I'm going to temporarily erase that, and I'm going to do my jumps. 1, 2, and I'm going to put zeros in their place. 3, 4, 5, 6, 7. And my answer is that. I think it's 1,360,000. If you want to, you can throw some commas in here. every third one. Okay, so that helps me to say it's 13,600,000. Now, if this were a negative 7, I would have gone in the opposite direction. Okay, so now we're going to talk about some multiplying and dividing scientific notation. So I'm going to bring my box. Oh, I lost my box. Okay. So, forgive me for this is a little bit wonky looking. But you might have an equation that says multiply these two things. 3.7 times 10 to the 8th times 6.8 times 10 to the negative 13th. These parentheses, it's understood that you're multiplying them. So the first thing you do is multiply just the numbers that are to the left of the decimal, or excuse me, the times symbol. So I'm doing 3 times 6.8. I'm going to write it down exactly the way I see it in the calculator, 20.4. Then I'm multiplying 10 to the 8th and 10 to the 13th. Now the rule for exponents when they have the same base is you add the exponents. So what that means is I would have negative 13 plus 8, which is negative 5. You could plug that into a calculator and you'll get the negative 5. So notice I've got my answer, but it's still just not in scientific notation. I need to have 2.04, but that's going to affect this negative 5. So what I've done is I've moved this guy to the left one spot, and notice I said it out loud. Moved it one spot, so I have 10 to the 1th. Sorry, 10 to the 1st. And then times 10 to the 5th, negative 5th. Now, due to the associative property, I can do any order I want. I'm going to go ahead and multiply these exponents with the same base. Negative 5 plus 1 gives me negative 4. I'm sorry, I don't have that bottom part here. So, I'll just go ahead and type it out. 2.04 times 10. I have to do my superscript to the negative 4. And I've written it in scientific notation. So multiplying them is a little bit, I wouldn't say easier, but just a little bit different. Dividing is very, very similar. So notice I've got this 2.829 times 10 to the negative 9th divided by 3.45 times 10 to the negative 3rd. So just like in my multiplication, I'm going to group the number part and group the exponent part. So 2.829 divided by 3.45 gives me 0.82. Just write it down for now. Now, when you divide exponents that have like bases, you subtract the exponents. Let me say that again. When you're dividing and you have the same bases, which in this case are 10, you subtract the exponent. So, negative 9 minus negative 3. And if that's confusing, I'd say type it in the calculator exactly how you see it. It gives me negative 6. So I'm almost there, but this part at the beginning is not in scientific notation. I'm going to need to make it 8.2. So I move it to the right one spot so that becomes a negative 1. Now up here, I moved it to the left one spot and it was a positive number. So here on the division, I'm moving it to the right one spot. Where is it? Right one spot, and it's a negative. Again, I'm going to group these guys right here, the same bases, so that means negative 1 plus negative 6. That gives me 8.2 times 10, let me superscript it real quick, to the negative 7. And voila. So a lot of this you can do. Don't do it in your head, obviously. Don't write it down. Use the calculator. You saw on your midterm that you have a basic calculator where you can at least do something like this and not have to do really long division. Now, I saw on one of your works that you have a problem like this. I'm going to table this problem for another video. I think that deserves to stand all by itself. Remember, when you look at this, do not panic. Don't panic. Okay, if you need anything, feel free to let me know. Thanks again. Bye-bye.